So today I'm going to analyze 3 ways that the town of Belmont can take to become more environmentally friendly. First up is school lunch trays. I interviewed Mr. Brown, who is the supervisor of food services of Belmont schools, and he states that the cost of our now styrofoam trays are 4 cents a piece. Biodegradable trays would be 8 cents a piece, and washable trays would initially cost $7, and it takes 50 cents to wash a rack of 12 trays, which will equal 24 cents a tray. Looking at these numbers, it is clear that styrofoam trays, the ones that we use now, are the least costly. Mr. Brown also shed some light on trays used in the month of May this year. In May, there were 28,625 meals served for all schools in Belmont. But we have to subtract roughly 3,000 meals because the high school has an option of getting a lunch wrap, which comes with a paper plate. So the grand total would be 25,625 meals, and every meal comes with a tray. So multiply 25,625 by 4 cents, then 8 cents, then 24 cents, and you get a total of 1,025, 2,050, and $6,150 respectively. Let's think of it this way. If the school was a PC firm in a long-term equilibrium, trays would be part of the ATC curve, average total cost curve. If the school changed to biodegradable trays, ATC increases, and if the school switched to reusable trays, ATC increases even more, and it would not be looking good for a PC firm. In addition, it would cost the town even more money to make these changes because all 4 elementary schools in Belmont do not have the dishwashers needed to wash reusable trays, and in fact, they don't even have space for one. This is according to Mr. Brown. However, the town can still make this happen if they really wanted to. Suppose that the town uses fiscal policy to invest in washers and reusable trays. By increasing government spending and running a deficit, the town will invest in washers. On the ADAS model, the aggregate demand will shift right because the town is increasing investment and consumption. The town can also engage in contractionary fiscal policy, where it can raise taxes, thus creating more revenue and paying for washers and reusable trays. Second on my list is solar panels. When it comes to electricity and how much power that we use, the numbers are pretty high today because of our cool gadgets such as phones, iPods, TVs, etc. According to the United States Energy Information Administration, the average annual consumption for a U.S. utility consumer is 11,280 kilowatt-hour. Under Belmont Municipal Light Department rates, which is 15 cents per kilowatt-hour, this average family would have to pay $1,721.44 of electricity for 1 year. Now imagine not just one family, but a whole high school instead. By using solar panels, this could save a tremendous amount of money for the school and town each year. At John Jay High School, Cross River, New York, they have 216 solar panels that has a total size of about 50 kilowatts. According to Solar Gains Company, a typical 5 kilowatt installation costs $14,000. So theoretically, 50 kilowatts would cost $140,000. This 50 kilowatts can generate a yearly output of 57,679 kilowatt hour. This output, multiplied by BMLD's rate for schools of around 13 cents, equals $7,475.78 saved. According to the definition of accounting profit, which is total revenue minus total explicit costs were the $140,000 and the revenues were the $7,475.78 each year. To find out how long it takes for the town to start gaining from this investment, we have to take $140,000 and divide it by $7,475.78, which is around 18.73 years. This means it takes roughly 18 3/4 of a year before Belmont begins to gain money from the installation of solar panels. Third on my list is walking, biking, carpooling, and etc. How does this affect the ADAS model? Because of the multiplier effect. According to ManQ, the multiplier effect is the additional shifts in AD that results when fiscal policy increases/decreases income and thereby increases/decreases consumer spending. To help the environment by encouraging people not to use cars, the town of Belmont could impose a new tax on people who use cars. This will reduce consumption and shift the aggregate demand left. The question is, how much left? Let's say the marginal propensity to consume, which is the likelihood of you spending the next dollar you earn, is 3/4. The multiplier is equal to 1 divided by 1 minus 3/4, which is 4. If the new car tax reduces the spending on gas by $10 million, the actual contraction of aggregate demand is $40 million.